Hello everyone, welcome back to my channel, and today we're going together solve the ugly number 2. So this problem is very interesting problem where we use both the hash map and the heap together to solve this one. So for the ugly number, we need to find the sequence, and then each number in this sequence is represented by the 2 to the power of m. So 3 to the power of n and 5 to the power of k. So we need to get it in order. It means that this array need to be sorted. However, like if we just maybe look through all of the cases and then sort it, so that is too much, and then we cannot do it. So instead we have another approach, and then so somehow like let's simulate it together. So for example, in here we have 1, right? And then what is 1? 1 is the 2 to the power of 0, 3 to the power of 0, and the 5 to the power of 0, and then this one we have the 1. And similarly we have the 2, that is the 2 to the power of 1, 3 to the power of 0, and the 5 to the power of 0. We have the 2, and next one we will have 2 power of 0, 3 to the power of 1, and 5 to the power of 0. This one is a 3. Okay, so maybe in this if we stop in this example and somehow like we can think about something like the bit manipulation. However, like it is very difficult because like in the next one you will see that like in here that is not like the things for the bit manipulation of these things. So what is the next number? So in here that is 2 power of 2 and 3 to the power of 0 and the 5 to the power of 0. So this is the 4. So here like it also simulates the sequence for us. And then so it looks like it is more difficult for us to solve. And then so we need to come up with another strategy, and here that we reduce the Min-Heap. For example, so why that is the Min-Heap? So you can see that in here, if we can find the next number and we just pushing the new number in the heap, and somehow we can always get the top of the heap, which is the smallest number, and then all of the elements in the heap will be sorted. So in here, how can we do this? And then firstly we can see that like, okay, let me simulate this one. Let's say that for now we have the heap that is only have one element, which is the 1, and then we will pop it out, that is the 1, right? And we have the set of the 3 numbers, that is the 2, 3, and the 5. Okay, so we construct the new heap using the smallest element in the heap, right? Because like if we have the new smallest element in the maybe in the sequence, it need to be constructed from the previous smallest element. Okay, so for now, if we multiply each element with the 1, 1 by 2, 1 by 3, and 1 by 5, so we will have the 2, we have the 3, and also we have the 5 in the heap, right? We have 3 elements in the heaps. We have 3 elements in the heaps. And then so next, because like for now the next candidate would be 2, and then we still have the set of 2, 3, and 5, right? We construct the new heap from this point. We multiply this one here, multiply this one here, and also in here as well. So what do we have? So in here we can see that like we can construct the new heap with the previous elements as well. For example, like in here we have the 3, right? For now that is the smallest element, and 2 by 2 that is the 4, and in here we have the 5, right? And also 2 by 5 that is the also we have the 6, right? That is 2 by 3, and then we also have the 10. Okay, we have the new heap. Okay, so you can see that in here that is the matching between the number in the sequence with the element we get from the heap, right? So this is the second element, this one is the first, this is the second one. And then so when we construct the new heap in here, and then so next iteration we will get the top of the heap out of the heap again, and then we construct the new heap, right? We construct the new heap. So here like you can see that like for now we will have the 4 as the top of the heap, and then following by the 5, following by the 6, and then so somehow like in here if you get the because like in here we have the special case. So here like if we multiply the 3 by 2 in here, and again we will see another 6 element, and this is the value of 6, right? and then because like it is hand already in the heap, and then so we don't need to introduce it again to the heap. So that's why, because like if you put it here and then when we pop out the smallest element, and then it would be like duplicated. Indeed that is the case like when you visit the 1 2 power 1 2 to the power of 1, 3 to the power of 1, and 5 to the power of 0. You visit the 2 and then you visit the 3 again. So that is the reason why like we have some kind of duplication. Okay, so to reduce like or like to manage this special case, and then we can do the things like we can use the hash map to check that is that element in the heap or not, right? And let's say that if we can use the hash map to exclude the duplicated element in here, and then we can add the next element. Also like here, that is a 10, right? That is a value here. And then we also 3 by 5, we have the 15th. Okay, we have the 15. We can construct the new heap, and by getting the next element in here, I mean the smallest element. Let's say that for now, what if the n that is only equal to 4? And then somehow you can see that this is the first iteration, this is the second iteration, this is the third iteration, right? We get our number of the 3, and then in the next iteration, that is the 4, and then we can get the nth element in the sequence. Okay, so you can see that in this case, like we just need to iterate through a maximum of n iterations, and then we can get the result. However, like in here, because like for each step, and then we need to push a lot of the elements into the heap. So that means that like we are sacrificing the memory to the time complexity, right? Yeah, so but I think that this one is manageable for the Python. For example, like in here, if we just stop in here, and then we have a lot of the memory. However, like yeah, sometimes like that is very difficult for us to reduce the time complexity. Yeah, so yeah, so I think that with this observation, and then somehow we can program it together. Problem I have done it long time ago, and a lot of the people say that like we cannot approach in this case because of the duplications. However, like with the duplications, we can remove like the duplication effectively using the hash map. Yeah, so just create the min heap first, because we always get the smallest element in the heap, and then we will initialize that with the first element in the sequence, and then so that is the 1, right? And then we need to get the heapify of the min heap to make sure that it becomes the heap, and then we need to keep check the existing element in the heap by using a hash map. And so for now, we just need to iterate through all of the iterations with the maximum iteration is n minus 1, right? Of n. And then so we always get the top of the heap, that is the element, by using the heap pop, and then we get the top element of the min heap, and then with this element, and then we calculate the next element we will push into the heap. So let's say that that is the multiplication of 2, that is equal to 11 by 2, and the multiplication of 3, that is the 11 by 3, and then multiplication of 5, that is equal to 11 and by 5. So for now we will check that if the multiplication of 2, if it's not in the hash map, and then somehow like we are safely push this number into the heap, right? Yeah, so that is the min heap, and the element by 2. Sorry, we just put the element multiplication of 2, right? We have already done it before. So for now we need to keep the hash map to check that this element is like in the heap. So yeah, we have already visited this number. So yeah, we check the multiplication of 2 3 for the hash map, and then we have the heap push for the min heap, and then the multiplication of 3. Okay, so and then we need to get the hash map, and mult of 3 equal to 1, and if the multiplication of 5 not in the hash map, and then we can push it to the heap. is it a 5? And then we keep checking it using the HashMap. Okay, so for now we are safely return the element. Okay. Okay, HashMap is not defined because my typos error. Okay, so yeah, let's submit. Okay, I think it's work. And then in here, like you can see that like we also efficient in terms of the memory. Yeah, so I think this one is very interesting one, even though like the acceptance rate is like, I think it is low. Yeah, but I mean that like come up with this strategy is very difficult. However, like yeah, it takes time for us to practice, and I must say that like the heap is like one of the most important like data structure for us to study, and then the heap is very nice because like we always can get the smallest element using the min heap, or like we always can get the maximum element using the max heap, for example. That is very efficient, and then this one is also it is the priority queued, and that is very common questions in the interview. So yeah, I think that like it would be helpful for you to practice by yourself. But yes, so thank you so much for watching my video, and if you like and if you want to give me more motivations in the future to make more videos for you guys, please give me subscribe. And yeah, again, thank you so much for watching my video, and see you next time.